2 video by going over some rules of integration. If you want to integrate a constant times a function dx from a to b, the constant can come out in front. Instead of having the constant inside the integral, you can bring it in front and still integrate from a to b. If you have the integral of a sum, the integral of f of x plus g of x dx. If you have the integral of a sum, you could sum up the integrals. You can take the integral of f of x dx and then add the integral of g of x dx. Even if you were to subtract them, f of x minus the integral of f of x minus g of x dx. This is the integral of f of x dx minus the integral of g of x dx. Whenever you have an equation where you have, say, 2 symbols, if you have a plus or minus b plus c minus d plus minus e. Some of their symbols or in the location where the symbol should be, there are 2 symbols. Let me just write one more. If you want to read the top one, then whenever there are 2 symbols, you should read the top one. For example, this would be a plus b plus c minus d plus e minus f. I always read the top one. It also means a minus b plus c minus d minus e plus f. That's the second equation. This is shorthand for 2 equations. Whenever you have an option, don't say always pick, oh, I'm going to read the negative. No. Either you always read the top symbol if there's 2 of them, or always read the bottom symbol whenever there's 2 of them. Okay, so if you have a sum and you're integrating it, you can do the integral separately. That's what this last equation says. And in terms of limits of integration, they would both, on the right side, be integrals from a to b. Okay. There's some more that we should just put down. If you have the integral of some function dx and it goes from a to a, if you think of the function itself, say the graph of the function, say it looks like that, well, if you were to go from a to b, well, the integral would be this area in the middle. The problem is we're not going there is no middle. We're going from a to a. That integral is 0. That area is 0. And here's another important one. This I use a lot. If you integrate from a to b of f of x dx, you can switch the order of the limits. You can go from b to a of f of x dx, except they differ by a minus sign, that they're not outright equal. If you switch the order of the integration, then you have to put a minus in front. And sometimes that will make life easier. Half the time, I bet. f of x dx, that is the antiderivative of little f of x, equals big F of x. That is, the derivative of big F is little f. If the derivative of this function gives you that function, then the integral of that function gives you back f. Okay. If that's true, then when we say the integral of f of x dx from a to b, well, this is going to be f of x from a to b. First we plug in the top value minus, and then we plug in the lower value. Real quickly, I want to show you why you don't have to say plus c. That is, it's some function of x plus a constant. Fine, you're right. But now, if you're going to integrate from a to b of little f of x dx, well, you get big F of x plus c from a to b. Now, when you plug b in for x, you'll get f for b plus c. Minus, now you plug a in. You'll get f of a plus c. Plus c, plus c, we subtract them. They cancel. C, take away c cancels. And then you're left with f for b minus what's left in the parentheses, f of a. So you don't have to ever say plus c, because it will always cancel out. Okay, there wasn't much in this first video. Next video we'll start doing some real integration.